All right, good morning, everyone. We are going to go ahead and get started. If you're just coming in, please feel free to introduce yourself in the chat. We'd love to see the organization, school, or district that you're joining from, as well as where you're joining from in Pennsylvania or otherwise. So thank you all so much for joining us for the Solar Schools webinar this morning. My name is Lane Frazee, and I'm the coordinator for PHEND Sustainability, a co-organizer for this event with the Philadelphia Solar Energy Association, or PSEA. PHEND Sustainability is a subnetwork of the Philadelphia Higher Education Network for Neighborhood Development, which addresses the need for a coordinated approach to education for sustainability across the K-16 spectrum in the Delaware Valley. And I'm really delighted to see so many folks joining both from our stomping grounds over in Eastern PA and all over the state as well. So for that, we really have to thank our partners for this webinar, the Center for School Study Councils from the University of Pennsylvania's Graduate School of Education, PA Solar Center, Generation 180, and the Delaware Valley Regional Planning Commission. So thank you all so much for making sure this event got to the people that it needed to. And finally, before I turn it over to Liz Robinson, my co-organizer from PSEA, I will just briefly go over a couple Zoom housekeeping items. So as Liz mentioned, this meeting is being recorded and the recording will be sent out at the end of next week. I will also be sending some helpful links through the chat during the presentation, and these will be sent in a post-meeting email along with the slides, so you can access those after the presentation. Please feel free to engage freely in the chat. We'd love for folks to connect with each other, share information. That is what we are all about. If you have a quick clarifying question about something one of the speakers said, please send it through the chat and we'd be happy to pause and answer it during the presentation. There's a lot of technical nitty-gritty information that we'll be covering, and we want to make sure that everything is clear, so please don't hesitate to ask for clarification. If you have a question that requires a longer answer or is just better suited for discussion, you can still submit it through the chat at any time or through the Q&A function, and a speaker will just respond to it during the Q&A portion at the end. So now I will turn it over to Liz Robinson, the Executive Director of the Philadelphia Solar Energy Association, who's going to introduce today's speakers and get us started.
Thanks, Lane, and thanks everybody for joining us this morning. We've got a great, very, very experienced group of speakers for you today. Dave Althoff, who is currently the Director of the Energy Programs Office at the PA Department of Environmental Protection, will start off. Dave has very, very deep experience in solar and clean energy broadly, and has been with the DEP for a number of years. I'm the director of the Philadelphia Solar Energy Association, and my background before PSEA is frankly in the energy efficiency space. So lots of you may know me from the Energy Coordinating Agency and the Keystone Energy Efficiency Alliance and other organizations. Ron Celentano is the president of the Pennsylvania Solar and Storage Industries Association. Ron wears a number of hats at all times. He also has his own consulting business, Celentano Energy Services, and is a very active technical director of PSEA, with deep, deep experience in photovoltaics, training, consulting, inspection, installation, you name it, Ron can do it. And Roger Clark, our last speaker, is retired now, but his last position was being the director of the Sustainable Development Fund in Philadelphia, which is part of the Reinvestment Fund. Many of you know Roger very well. He's both an attorney and has a long service in public organizations, including the state of Pennsylvania, and developed along the way a great deal of expertise in finance. So you can see how we divide each other, complement each other. So I'll start off the presentation. And let's see, Elaine, you're going to advance slides, right? Great.
Yes, let me know when you're ready.
We can go to the next one. I do want to really thank everybody who's been partnering with us in this project, and we will remain in partnership. So what is happening here is we're developing, I would call it a statewide coordination of effort to support schools going solar. This is our agenda, and as you can see, it's very straightforward. Please put any questions that you have for us in the chat. We will answer, as Lane said, the basic ones we'll answer as we go, but we will also leave plenty of time at the end of the presentation for questions and discussion. Thanks.
Welcome, everybody. My name is Dave Altoff. I'm the Director of the Energy Programs Office at the Pennsylvania Department of Environmental Protection. A little background on the office and myself is that we are the DOE recognized state energy office. We are also the climate program for Pennsylvania. So that affords us some unique opportunities to really lean into energy and the emissions benefits from a clean energy economy. Myself, I've been working at the Department of Environmental Protection for 30 years, and 25 of that in our pollution prevention, energy, climate office. So, developed a lot of great relationships along the way. I've been involved in a number of initiatives, and I can tell you that, solar is something that is absolutely enduring. And I want to thank Liz and Ron and Roger for all their support over the years. And in addition to that, a staff member from the Energy Programs Office, Mr. Robert Young, he's on the call as well. I had asked him and Liz and Ron to really put their heads together and figure out what should we be doing in this moment of the Inflation Reduction Act, in this moment of the Investment, Infrastructure, and Jobs Act. And what could we do that would be really of benefit to sort of supercharge deployment of solar in Pennsylvania? And this webinar series, this series of events that we're going to talk about today is really the result of some folks really in that sector putting their heads together and saying, what is really best? What should we be talking to folks about? And this really goes back to, about 5 years ago, we launched an initiative, and I still love to talk about it, which was called Finding Pennsylvania's Solar Future. We worked together with the US DOE to sort of lay down some strategies as to how to get to 10% solar by 2030. And that means 10% of all of our electricity use in Pennsylvania being generated from in-state solar by 2030. And that was an aspirational goal, a stretch goal. But it allowed us to have a lot of conversations with about 500 stakeholders from the standpoint of what really needs to happen to get us there. How do we get on a pathway towards, achieving that aspirational goal by 2030 such that it benefits our environment? And a number of those things sort of have happened now along the way. But a big piece of that was how are we able to monetize the tax credits for solar for nonprofits and schools? And that just happened with regards to IRA. And so it's really unlocking this segment. It's really unlocking this opportunity. While we've been focusing on land use concerns and permitting and working together with municipal entities who are essentially thinking about ordinance with regards to solar deployment, there's all manner of opportunities, but this is one that has really recently been unlocked. And I think that we should think about this from the standpoint of schools as a resiliency hub within a neighborhood. And so while we're talking about being able to deploy an energy generation asset, which provides you with cost certainty for electrical energy generation at your facility, the time is now to also think about, well, what else does that provide to me and to my community from a resiliency standpoint, from other operations within your school or your school district, whether that be electric busing, whether that be your kitchen operations, for electrification of your cafeterias, whether that's the tools that you're using, your HVAC systems. There's all manner of things that really can utilize, an energy generation source on your property, on your roof, that is providing to you cost certainty and electric generation for many, many years to come. This combined together with energy storage assets like batteries, the batteries that will be in these electrified buses, are also grid assets. And they also open up the opportunity to not only consume power from your solar array that you may have on your school, but also to provide that benefit, that electric generation benefit, back into the grid when it's needed most, during times of emergency, high energy use periods, high cost periods. So you should think about that not just as an asset to provide energy for your school, but an asset for your community. Many of our schools are shelters as well. And so providing that resiliency tied together with energy storage, these are real community opportunities to lean into that are now being unlocked through the IRA and IIJA opportunities. So, with that, I just wanted to make sure to level set and say, just to think about all of the opportunities. I think that we also have gotten to a place whereby, this is not too early, but it's not too late. Folks have been deploying solar in Pennsylvania. They've been deploying solar on schools in Pennsylvania. I have some numbers here that were provided by my staff person, Mr. Robert Young, and I just want to go over them with you because I think it's instructive. Is that, as of the end of 2021, and so now we're in 2023, we have nearly 30 megawatts of solar installed at over 100 schools in Pennsylvania. So if you're thinking about going solar, you're not the first one. There's 100 other folks who have done this before, right? And so who have stories to tell, who have best practices to lean into. So this is a really, really good number. On top of that, over the years, we have been providing incentives from various different programs and grant programs over the years. So of those 108 schools, approximately 30 megawatts of solar, we have been involved with about 30 of those schools and providing about 10 megawatts in about $15 million of grant awards. So there is ways to obtain funding to help supplement the deployment of these solar energy resources. And this is something that we've done before. So, unfortunately, as I said before, I say unfortunately because, I'm getting older, right? And so, I've been here for 25 years. And, I can remember being in the energy office in the late 90s, early 2000s, when we did not have a megawatt of solar installed in Pennsylvania. Not have a megawatt of solar installed in Pennsylvania. Now I just told you that we have 30 megawatts of solar installed at schools. And if we haven't gotten there already, we're really close. We're close to having a gigawatt of solar installed in Pennsylvania. So that's 1,000 megawatts. So during my time, we didn't have a megawatt, and now we nearly have 1,000 megawatts. And at some point in the future, somebody's going to say, I can remember when we didn't have a gigawatt of solar installed in Pennsylvania, right? Because we will get to 10 gigawatts of solar or maybe 100 gigawatts of solar, right? Like we are on that track. And so now is really the time for this to take off. We want to move into that next space whereby it's not really like a big deal that you installed solar, that it's not a big deal that you built resiliency for a distributed energy generation asset within your community that then interplays with your local distribution grid. That time is really now, and we know how to do it. And so that's what this school's toolkit is all about. It's about that this can be done. We have examples and case studies. There's financing opportunities out there. There's a workforce out there. This can be deployed at your property if you want it. And I believe we're going to describe some of those reasons for that to happen and some of the reasons why you should want it. So with that, I will kick it back to Liz to continue on with your slides.
Thank you so much, Dave. That was perfect. These are two schools in Pennsylvania that have gone solar in this illustration. So Dave's absolutely right. There are many, many wonderful examples to learn from. And I'm really enjoying getting to know the schools and the people behind them. They're wonderful examples. Lane, next slide. So the reason really that we're doing the Solar Schools Toolkit is in response to the Inflation Reduction Act. The IRA is an absolute game changer for clean energy in the United States. It provides almost 370 billion with a B dollars for climate action. And we're focusing today on the nature of those changes for schools and other nonprofits. But the IRA has really changed the game. This is simply a chart showing the expected reduction in greenhouse gas emissions that will result from the IRA. And as you can see, it really is, the IRA is a significant and unprecedented shift from a fossil-based economy to a clean energy economy. And solar will play a very significant role in that change. Great, thank you. So the investment tax credit, as changed, as altered by the IRA, is completely different. So the base level of the tax credit is now 30% for solar. So if your project is smaller than a megawatt, there are very few requirements for the 30% tax credit. If your system is larger than a megawatt, it does need to meet both prevailing wage and some apprenticeship requirements. You probably know that all public schools already need to meet prevailing wage in their construction projects. So that's nothing new. The only new wrinkle will be apprenticeship requirements. And we will provide those to you as in the toolkit. For the very first time, the tax credit now includes battery storage. So the entire installed cost, including battery storage, can be part of this 30%. It also includes interconnection costs. So that is also brand new. So it's really the entire project cost can be qualified for the 30%. So that's the minimum. In addition to the baseline are a bunch of adders, or a number of adders. The first one on this slide is a 10% adder for domestic content. That means modules that are manufactured in America. And these standards are laid out under a set of guidelines called Buy America. The next adder, which is very, very important for Pennsylvania, is the Energy Communities adder. This is 10%, and 60% easily of Pennsylvania is classified as an energy community. What this means is a community that has experienced fossil fuel production, basically. So community near a brownfield, a community near a closed coal mine, coal power plant, or with a lot of tax revenue from fossil fuel production. So easily the second, the western half of the state, the central part of the state, it's the map, which we've linked to here, and I encourage you to use this link. This map will show you where these energy communities are, but it is about 2/3 of the landmass of Pennsylvania. Most of central and western PA, not too much in the east. There's another 10% adder for low-income census tracts. This one is going to be very different than the others, and the final guidance on this we're still waiting for, but the way it's framed in the preliminary guidance is that it will be fiercely competitive nationally. It will only exist for 2 years, and it will probably start in September. It's going to be administered likely by the Department of Energy, not by the IRS. And it will be a process that is capped each of the 2 years by the amount of megawatts that it will support. So this, the final guidelines are still coming out. We expect them by the end of June. But this one, in order to qualify, if you are in, let's say, Norristown or Pottstown or Philadelphia, and you're in, you're in a low-income census tract, I would really encourage you to think about getting ready for this low-income adder. All you'll probably need is a preliminary bid. So you would, in order to qualify, you would contact a qualified solar installer, get a preliminary bid for your project. It doesn't have to be the final bid, but a preliminary bid for the project, and you'll be ready to submit that to the DOE when they open the gate, essentially. Frankly, California and New York are bragging that they can take the entire amount. So in order for Pennsylvania schools to be participating in the low-income adder, schools really do have to be ready. So you will have to prepare in the coming months for that opportunity. So I really encourage you to think about doing that. And you'll find this preliminary guidance at the IRS is quite detailed, and we'll guide you there. Next.
Can you entertain a question of that specifically?
Sure.
I just referred that, and it's a very, very hot and heavy issue in Phoenixville because we have Crombie Station. I just clicked on the link and I see 2 levels that are shown with the symbols. Census tract with a coal closure directly adjoins a tract with a coal closure. Do you or anybody know whether that distinction allows or disallows in the directly adjoins a tract with a coal closure?
Honestly, Mark, I'd have to look at it really closely. I can't answer that off the top.
Okay.
And
my understanding is if you're directly adjacent, you are eligible, so that counts. But
Okay, because
we have to confirm with the final rules as they come out.
Okay, because I think there's 2 other maps floating out there. One that I only know as NMC, and another one, a census tract map. So I think we've got 3 competing data sets here. So it'd be great if coming out of this, we could get some clarity on that.
Yeah,
yes.
The National Energy Technology Lab is working to that. They have some preliminary maps up there. The last I checked, the brownfield layer had not been put in, but that's happening as we speak, probably. So yes, it's a work in progress still.
Thank you.
So the other really huge change, and this is probably the equally important to the levels that we just talked about, is that for the first time ever, the tax credit is going to be available to tax exempt entities like schools, nonprofit organizations, municipal governments, electric co-ops. This will occur in the form of something being called a direct payment. Direct payment. Reading the English language, I think this means that the IRS is going to cut you a check. We are waiting for final guidance here. So this would mean that if you qualified for 30 or 40 or 50% of tax credit, you would receive that amount of money in the form of a direct payment from the federal government. Exactly when you'll get that check, I don't know yet. We're waiting, as I say, for final guidance here. Whether that'll come all at once, whether it'll come half at the beginning and half at the end of the project, we don't know yet. We do expect this to settle down by the end of June, and that'll be, the final guidance will be included in the toolkit. But we want to alert you to this now so that you're able to plan through the summer. Next, please. The advantages of going solar are numerous, and this is actually not an exhaustive list, but I can't think of any entity for whom there are more advantages than schools. Schools are really unique in their requirements, and the advantages to schools of going solar are really, really very significant. So the obvious one to start is energy bill savings. We are going to go into these in a lot more depth in this webinar, so I'm just going to give you kind of a high-level overview here. But you will offset your electricity consumption by your solar production. You'll also have some reduction in your peak, although it may not be significant. You'll be able to earn revenue as the sun is shining. You're going to be earning solar renewable energy credits, and you can sell those in the market. As Dave mentioned, solar is very important to schools to improve their own resilience, and in some cases, the resilience of the community. If you have battery storage particularly, and electric school buses in the future will be used as battery storage for schools, you can rely on that for emergency power operation. You're obviously improving the environment by reducing carbon emissions, and you're helping to meet your own local goals of your own local jurisdiction, your township, your municipality, but also the state and national goals, which have become increasingly aggressive as climate change has proceeded. This is a factor that's probably not quite as important as offsetting your electricity bill, but very, very important. And we've seen this year. You will be able to avoid the full impact of future rate hikes. So you'll be able to stabilize your energy bill, your energy costs. And that's incredibly important to schools. Stabilizing any item in your budget, particularly an item like energy, is very, very key. And then finally, just creating educational opportunities both for students and your faculty, your staff. And this is becoming more and more important as the solar industry continues to expand. Solar is now the fastest growing energy resource in the world and in the United States. It desperately needs more workers. Solar workforce is, frankly, doubling, and as we speak, and Pennsylvania is a very important state in that process. Next slide, Lee. So I'm going to turn it over here to Ron Celentano.
Yeah, good morning, everyone. Just to get through some of the nitty-gritty a little bit on the obvious components of what makes up a solar photovoltaic system or PV system. The two most important components are the solar PV modules and the inverter. And then there's also the racking system that holds the modules in place, and sometimes it also holds the inverter in place. The balance of system is really all the components that are, that consists of the rest of the system, the wiring, the circuit breakers, and other components and devices. And then there's battery storage, which is an option. You don't need to have battery storage. In fact, I'd say 95% of solar systems out there right now don't have any kind of storage at all. It still works fine. The grid almost acts as sort of that battery, if you will, a little bit. But we'll go over that in a little bit. And then there's the monitoring system that is important for keeping track of the data and the performance of that system to make sure it's operating properly and for educational purposes. Next slide, please. So on the upper section here, the solar types of modules, the most popular module that's been for several years now is a silicon-based module. It's basically an electronic semiconductor that is directly converting sunlight to a DC direct current electricity. There's other types of solar PV out there, thin film, other types of it, but because of the time here that we have to discuss it, I'm just going to go over the silicon-based module that is most commonly used now. And in the upper left, you see that it starts off with a solar cell that is, that is the layers of different types of silicon material and other materials that are mixed with that in order to give it its speciality of being able to take that sunlight photon and which, by the way, will basically strike electrons on that silicon cell in some of the of the layers that are in there, and basically carries that energy and converts it over to electricity as it goes through the wiring, the very thin wiring that you see in that cell. So those cells are wired in series and in parallel in the module that you see on the right. And that module is then wired together in series to make up a string. A string of modules might be 10 to 15 modules wired negative to positive, making one string. And those strings are then combined into an array. So when you hear of let's say a 50 kW system on top of a building, it would be the sum of all those modules that make up that entire array. On the middle slide is showing, or middle picture is showing, the layers that comprise of that solar module. It's, basically you have your glass, an anti-reflective glass, aluminum framing. You have the solar cells that I just talked about all together. You want to encapsulate those with EVA it's a type of materials, just like you're vacuum packaging that, so it protects the modules, these electronics from the elements, the rain, whatever, from the outdoors. And then you have a back sheet of Tedlar, which is a piece of plastic, special plastic. And then you have the junction box, where all this wiring that comes out of the module, it basically come out with two wires. That is a positive and a negative, and that's what you're left with. And on the right side is that assembled module that really comes out of that blow up there. Down below, the inverters, the left side is showing string inverters, where I talked about there's a string of the solar modules all coming together. So an inverter may have, depending on its size, could have 3 to 5 to 10 inputs for its string. So you have this string of 10 solar modules or 15 solar modules wired in series. That would be a string that would plug into one of these inverters. On the right are either microinverters or devices that are used that are mounted behind each solar module. So a microinverter is, you would basically be converting a single solar panel or solar module with a microinverter behind it right to alternating current. And that's what's really important here. These inverters basically synchronize with the grids, with the sine waves that are coming off the grid, and then it's usable power at that point, right, to meet all your loads. The other devices that might be mounted behind the solar modules are basically communicating with each other, still on direct current, and then going into the inverter. But it's basically to isolate any single module. If there was shading on a module, the rest of the modules in that string could operate in their full potential. Or if there's an outage, has the ability to shut everything down to a safe voltage, so that it's safe for anyone to operate up on the roof. Next slide, please. So the racking system is, of course, the other important part of holding all these solar modules together. And you probably have seen many of these modules on homes, on pitched roofs, wooden roofs, shingled roofs, and those racking systems are attached onto the roof. They're penetrating into the roof. But most commercial buildings have flat roofs, and it's good to always avoid, if you can, to not penetrate into those roofs at all. And that's what is shown here. So this is pretty common for a lot of flat roofs on commercial buildings. But basically, you have aluminum pans, or it could be plastic material that is holding the modules in place. And then you have ballast, which is like patio block or something of some sort, that is holding the module down. Typically, these modules are not more than 5 to 10 degrees in a tilt. On the middle slide is showing, might be a little surprising to see that you have modules facing two different directions, but in this case, they're facing east and west. So you actually can get a little bit more capacity on a roof by having a system like that. And on the right side is a ground-mounted system, where it also could be a pole-mounted type of system where you could have tracking of the array. But in this particular picture, it's just a fixed tilted ground-mounted system. And these the hardware here, or the posts there are actually pounded into the ground in most cases, so no concrete is used at all. However, you could also have these with a large concrete ballast that doesn't penetrate even into the ground, and that's maybe what is often or can be used in brownfields. So it's a big ballasted system that is basically supported underneath that framework. Down below is a balance of systems. We have circuit breakers, fuses, basically overcurrent protection devices that are mounted between each of the components for safety, and then there's, of course, there's the wiring between everything. And then on the right side, it's a little bit old school. It's not as used as much as it had been in the past. It's a combiner box. You're taking all those strings I was talking about, and you're combining them into heavier conduit that comes out and goes into a central inverter. The central larger inverters are not used as often as they have been more in the recent years. We have a lot of the smaller string inverters, which makes it a little bit easier for a redundancy application. Next slide, please. And then finally, there's the storage that is, again, optional. And it's, again, used for resiliency. Like if there's an outage, you can then continue to provide electricity to critical loads in part of the building. I do think it's better to have stationary storage rather than, you may have EVs with storage, and that has yet to mature as a means for providing storage. The stationary storage is very dedicated for that purpose. It also could be used for helping reducing your electric bills by reducing the demand charges or time of use rates, where you are using the storage and the solar at the same time for reducing your high period of costly electricity. Then there's a monitoring system, which is always used, and that's giving you, of course, feedback on how your system is performing. It's also helping to determine from an operating maintenance perspective, if something is down, maybe there's an inverter that's down, you can identify it from this point, and you can download data down to a very, very granular level. It's also, of course, good for classroom education for students to do some calculations and see how the system is performing as well. Having a weather station on site is also a valued thing, so you can see how well is the system performing as compared to what the prediction would be. Next slide, please. Okay, next. Back to you, Liz.
Thanks, Ron. So now we're going to really start into the toolkit as a preview. So we've organized the toolkit in 10 steps, and just to make it easy to follow along. So Lane, if you advance the next slide. The first step is to build a team. And your team doesn't have to be big. It can be quite small or large, depending on what you prefer. But if possible, include real resources on your team. Include people who can bring hard data. You'll need your energy consumption data, your electricity bill, and people who can bring other forms of data to you. You'll need decision makers, people who can make the decision at each decision point. And of course, you always need worker bees, the folks who are just determined to get the job done. So examples could be facility manager for your school or your district. That's an ideal person. Your chief finance officer will be immeasurably helpful in making the decisions about financing. And of course, champions. And this could be a person who's on the school board. It could be a local, it could be a parent. We've heard all kinds of stories about the champion who got this thing going and really got it done. You can also include students. Students, I would put in the champion category. They can be very inspiring and persistent, as you know. And you might want consultants at some point in your project. We're not assuming everybody will need a consultant. The toolkit will really make it possible for you to get much farther down the road without consultants. So you'll need fewer consultants, if you will, or you'll need them for less of the time. But you might want consultants, particularly if you've got, a thorny issue that you just need to untangle. So there are lots of good consulting resources in Pennsylvania, and we're going to go through a little bit of that with you in this webinar. Next slide. And back to Ron.
Yeah, so the two things that are, of course, the very first things you want to do when you assess whether solar will be an option or be a good idea for a school is where can the solar modules and equipment be located? But the other part of it is to look at your electric bill. And electric bills could be pretty confusing. I've seen several school electric bills that are quite confusing. This is a kind of a simpler one on the side. A commercial general service electric bill is you want to identify some of these things on the bill that are that help for you to figure out what savings can you achieve from having solar. And we have net metering in Pennsylvania, which is by law and regulation that provides anyone with solar to offset their electric usage full retail value, but it's based on just the energy part of it, not the KW demand part of it. And I'll talk about that a little bit. I mean, we have, when you look at your residential bill, you have typically a flat rate, a kWh, kilowatt hours of energy that's usage. So you could easily offset all of your electric usage, reduce your bill to pretty much to zero with having a system on your roof, depending on the size and your usage. For commercial buildings, however, it's a little different. You have things broken up. You have this other line item that's called the demand charge, and it's based on the KW, or the power, or the demand the demand of energy in a very short timeline. So I want to kind of quickly bring this up. Demand is really, I guess I make the relationship of, like in your car, you have an odometer and a speedometer. An odometer is the amount of mileage that you travel from point A to point B, and it could take 10 minutes. It could take 2 hours to get there. You're still going to get the same mileage you're traveling, but the speedometer is showing you what speed you're going at. And it's really the speedometer is representing or related to the KW, or the demand part of it. So what happens is when you're in your building, you have maybe so much energy usage over a period of time, but you have these spikes of draw of power. And maybe you have a water heater that comes on and is drawing so much KW. So it sets a watermark, if you will. At the beginning of the month, it starts off at zero, then you start drawing up power, and it sets a watermark of basically, okay, I'm drawing that much power. I may not turn that water heater on again for the rest of the month. It doesn't matter. I'm going to pay a charge on $1 per KW for that demand charge, even if I use it that one time. Now you maybe turn it on again, and now you bring on an air conditioning unit. Now you've increased that demand to another level of water line. That's now going to be your demand that you're going to be charged against. So and this could happen at any time. It could happen at 1 o'clock in the afternoon. It could happen at 7 in the morning. The solar doesn't necessarily offset that demand charge, because it's very synchronous to when the solar is happening relative to when that peak demand is happening. So that's why we like that, what Liz was saying before. You can't necessarily get much demand charge of offset from your bill. So what remains is a lot of it is just the energy charge. So we look at the distribution charges and the supply charges. The distribution charges are really what you're paying the local utility part of the bill, your PP&Ls, your PICOs, your MED-EDs. That's what you're going to be paying for there. And it's typically it's based on the energy usage, and there's a rate associated with that. And then that's where the demand charge really comes into play, though. It's the distribution charges where you have this high demand part of the bill. And that part of it is something that you may not be able to offset very much with solar. Then there's the supply charges. The supply charges are your, again, you could buy your electricity, your supply, your generation from the local utility, or that's where you can shop. You can buy this electricity from a third-party supplier, and often that does happen. You maybe get a lower rate for the electricity from that. So that's, again, the energy part. That's the part that you can reduce on the volumetric part of the bill. There's also a demand charge there too, and it's usually on the transmission part. It's usually bundled in with the supply charges part of the bill. the one thing I really want to emphasize here is that you really want to, it's best to stay with your local utility in order to get the net metering benefits, because the third-party suppliers aren't obligated to give you the credit that you could get otherwise from your local utility, which are obligated. And I just wanted to point out that the energy electric usage, and you see on the table on the right at the very bottom, there's the annual kW usage. That number is what is often used to get a sense of how much that capacity could be for your solar system. That goes into part of the analysis to determine that. So benchmarking is another important thing to determine what is your energy usage in the building. Can you identify where there's your lighting, your air conditioning, your hot water usage is, and what efficiency improvements can be made, because it's far more cost effective to reduce your energy usage with energy efficiency technologies, and then you could reduce your capacity for your solar part of the system to be installed. Other uses that you can consider looking at are the electric vehicle buses, charging stations, and just basically, as David was talking about, converting all your fossil fuel types of equipment over to electric, because that's how you be decarbonizing and providing solar to offset all that usage. So as I said before, the two things you want to first look at when you think about having solar is to, you look at your electric bill, but also location of where can you put the solar array and the inverters. Do you have a lot of open space on your roof? Do you have open land that's really not being used for anything? That could be an opportunity to use it there. On that roof, you have to consider the age of the roof. And how many years old is that roof that it may have to be replaced? The other thing is what other obstacles are on that roof? Are there a lot of condensers from the HVAC units that are covering a lot? That may limit the amount of solar modules that could be up there. The ground conditions are going to be, you could have park canopies with solar on them. That's a more expensive approach, but that's certainly a good one to consider. The orientation is just literally the orientation of the solar module to collect the most that you can from the sun. Safety is more about having fencing around, if it's a ground-mounted system, fencing around to protect anyone from tampering with the electronics, as well as even with disconnect systems or devices that are around the system. Interconnection point is how the system is tied into the electrical panel or the service that comes into the building. So you could have all of this come together, coming out of all the inverters, going into overcurrent protection devices, and tie into a circuit breaker into an electric panel, or it can be tied into the feeders going at the point in between the utility meter and the service panel, and that would be a supply side connection. And finally, you can there's a lot of different models that are out there, simulation models that are out there, but the one that's most common and easy to use is the PV Watts. It's been developed by National Renewable NREL, Renewable Energy Labs, or DOE. It's been out for well over 20 years. It's online, and you could basically put in simple inputs to see how much generation can be provided by a certain size system, depending on the zip code or whatever. So it works it's pretty effective and reasonably accurate. Next slide.
I just want to stress, this is Roger Clark, and welcome. Thank you for joining us. I want to stress that the philosophy of the solar toolkit is not that you become solar engineers, but rather you become educated consumers so that you can negotiate with your contractors and installers on a more equal playing field. So the previous slide of the step of potential for solar generation isn't, we expect you to design the final layout of the system, but to be able to come up with some general view of what it should be like so that you then can enter into the negotiations. The fourth step is to decide, how do you want to own your solar system? And there are essentially two different variations of this. The first is direct ownership. That's where it's actually your system, your property. It has the benefit that you aren't sharing the savings of the system with a third party. You're not paying a solar developer on a month-to-month basis for it because it's yours. But the disadvantage is you need to do a bit more work. You need to arrange the financing for your system. You need to select the solar installer. And then over time, you need to be maintaining the system. None of those are impossible tasks or even overwhelming tasks, but it's a little bit more work. It's also kind of, where is your school and your school district in thinking about solar? If you have no experience whatsoever, then maybe the second category, third-party ownership, might reduce the risk for you. You'll pay for that, but you'll have less risk. Maybe also you're in a situation where arranging financing is problematic for your school district. You've got some other big projects, you can't borrow more money, whatever it is, maybe third-party ownership is. And there are essentially two models that have been out there for third-party ownership. The one that's prevalent right now is the power purchase agreement. It's essentially a lease, but you're paying on the basis of the actual output, so many cents per kilowatt hour. The other model is a lease, like a typical hardware lease. You're leasing the equipment. It's based on some other fee, not on the output. And there are advantages and disadvantages of each of these. And so it's a matter of figuring out, how do I want to own my system or not? What's my appetite for that risk and that effort? Next slide. Step 5 is probably one of the most important ones, because you're not going to be interested in solar if it's not going to save you money. There are other benefits, as Liz said, environmental and resiliency and so on, that are very important. But if at the end of the day, this is going to increase your bills, you're probably going to have a hard time selling the project. What you ought to be doing is evaluating those costs and those savings over time, life cycle basis, and looking at, if I do nothing, what's going to happen to my electric bill and how will that go up over time? Versus if I do this, what are the costs? So it's a matter of sort of balancing all of this. There are three major revenue streams that will come in from your solar, and we've talked about these a little bit. First is the energy consumption, the kilowatt hours that you're using. We have net metering in Pennsylvania. So if your solar system is generating more power, say on a Saturday when your school is not open, the kilowatt hours go into the grid and then come back when you need them, and you figuratively spin the meter backwards so that power comes back for free. You're using the grid as a battery, essentially. In Pennsylvania, we have an expanded version of net metering called virtual meter aggregation that may have some application to schools. If your school has multiple accounts, you are able to, and they're all within 2 miles of each other, and they're all in the same entity's name. For example, you have the school building, and then you have a facility shed somewhere, and you have some lighting somewhere for the stadium or whatever. You can aggregate all of those accounts, even if they're not all connected to the same meter, the same account, so you can benefit and have the benefits of your generation apply to all of your electric accounts. So you're going to get money for that. You're going to get free kilowatt hours. There was a question about what happens if you generate more than you use. On instantaneously, you'll use the grid as a battery. You can use it at the times when your system's not generating. At the end of the year, the utilities must true up. So if you have excess generation, you do get paid for that, but you get paid at a wholesale rate. It's a lower rate. So generally, net metering is designed to bring you up to the generation level of your consumption, but not in excess of that. The second revenue stream potential is reduced demand. We talked about the problems of that. You'll probably see some demand savings occasionally if you happen to have the peak consumption coincident with the peak generation. It will bring that down a little bit. But other months, as Ron said, you'll have high usage and a cloud will go over for half an hour and bang, your demand is set without the solar. So probably not counting on that too much. SREC income, solar renewable energy certificates or solar renewable energy credits. In Pennsylvania, it's called alternative energy credits. But these are the attributes, the clean environmental attributes that say this is a kilowatt hour that's different than other kilowatt hours. And there are rules in Pennsylvania that mandate that electric utilities and electric generation suppliers provide or supply a certain amount of clean energy to their customers, and to have that system operate, there's this whole SREC system set up of tracking these kilowatt hours. And the impact is you can sell them in the marketplace. There are markets now. The credits can be bought by utility companies or electric generation suppliers, or by third parties who are interested just in greening up their performance. But SREC income is significant. A megawatt hour worth of solar right now is an SREC is worth about $47 or so. I think the last time I checked, Ron, correct me, but it's not insignificant. So SREC income is another revenue stream. Against that, you need to think about what's my O&M cost and what are my costs of financing. If I'm a direct ownership, I've got to borrow money probably. I'm going to have to pay some interest. What's that cost? So you balance all of this out. If it's a PPA, you've got to think of what are the fees I have to pay under that. The toolkit will talk about these in some detail. We've got a pro forma to help you figure out what is the financial story that my project has, and you'll be able to assume different escalation rates. For example, if you want to say what's the price electricity will be 15 years from now, you can set in the pro forma what do you assume for the escalation rate so you can test it. One of the problems you have to watch out for is that some folks will give you a far rosier picture of this, assuming electric rates are going to go up 4% a year. And so obviously this will be very helpful. Well, if they only go up 1% a year, you're not going to see quite the same benefits. So the pro forma lets you tease out those sensitivities and understand, is this a project that makes good financial sense for us or not? Let's go to the next slide. Okay, if you are doing direct ownership, this is an issue, step 6 of securing financing. That's one of your challenges. If you're doing a power purchase agreement or a third-party lease, the third party, the solar developer, is responsible for that. So they don't have to worry about it. But schools regularly raise capital all the time for various needs, be it large construction projects or sometimes just operating expenses. And so this is not totally foreign to school districts. So direct ownership may be something that many of you will be thinking about. There are 4 categories to look at. I would first look at what cash does the school district have on hand. There is a chart of accounts that the Department of Education and the Office of the Budget require school districts to use. So it will tell you in there, you can ask your school district, how much capital do we have in the capital reserve for capital projects? How much do we have of unassigned capital? Do we have any money that we might be able to put into this project? Because any cash you put in will reduce the amount that you need to borrow and reduce the cost of the project. So that's the first place, your own cash. Second are grants. Obviously, other people's money is the way you want to go to the extent that you can. The one warning we give, though, is that let's not make grants be the excuse that you don't move forward with your project. And right now, there's a lot of potential grant money coming. But if you wait and wait and wait and apply, but aren't successful, and then say, well, let's try it again, all you're doing is postponing your project and paying higher energy costs in those early years. So go after grants, but don't obsess about them. The exception to that, obviously, though, is the investment tax credit, direct payments. That is a no-brainer, because if you do that well and get the 30% plus the 10% for domestic, plus the 10% for an energy community, for example, those are all additive. So you've now cut the cost of your solar in half, literally. So the direct payments from ITC are absolutely something that you ought to go after. There are a variety of federal grant programs out there. There are state grant programs. Some of the state grant programs have been active in the past. Right now are dormant, but likely to expand. We have the Pennsylvania Energy Development Authority. We have the Commonwealth Financing Authority. We have a whole variety of programs, and the toolkit goes through each of those and gives you contact information and web links and so on to show how you approach that. Not all grants are cash, and let me just make sure people understand that. One very useful form of credit enhancement, for example, is a loan loss reserve. This is some entity saying, I will cover you if you can't make your payments, or if the economics don't work out, or if there's the production is failing. The lenders love loan loss reserves because it reduces their risk. If the school can't pay them, here's this other entity they can turn to. So that's a very useful tool. Maybe you won't use it at all, so it's not like you're putting money in your pocket, but it nonetheless reduces your borrowing costs. Third category are a whole variety of public finance options, and we're going to see more of these developing. We have EPA is a green power loan fund that's being developed. DOE has some energy technology funds out there. The state has been doing work on green banks. Local entities like Philadelphia and others have been doing green bank financing. And we have our Pennsylvania Sustainable Energy Funds, those regional funds created out of the electric restructuring cases back in the late 1990s. All of those are sources of capital that you might want to look at to help finance your project. School bonds I mentioned because schools are very used to that. One of the problems, though, is that the 30% formula for the investment tax credit drops to 6% if you're using tax-exempt financing. The portion that you finance through tax exempt, you only get a 6% ITC, not the 30%. So the grant or the tax exempt may actually not be in your interest, because the offset of the direct payment may offset whatever interest rate savings you would get by it being tax exempt. The key is longer term. You want long-term financing. You don't want 5-year, you want 20-year financing if you can get that. And a lot of these public finance entities are designed for that. And the fourth are private banks. And there are a lot of lenders out there. Your schools probably are using them already for different uses. There are lenders that are operating in Pennsylvania that have access to this, and we know all about that. Okay, step 7. Once you've got your team saying, let's move forward, this sounds real, then the next step is to actually find a solar installer and get some real numbers for your project. The toolkit has a generic RFP in it, goes through the key categories that you want to make sure that you ask information about so that you can make a smart decision. We're suggesting bidding the project both ways to help you decide what are the relative economic value. Should I own it directly versus third party? There may be different rates for that. Some developers may offer both models and could respond both ways. Others may say, no, we're just doing direct ownership, or no, we just do a PPA. So that's okay, but if you get a multiple bids from different ownership models, you'll be able to figure out what the best option is. And then send out that RFP to qualified installers, folks that have experience, expertise, certification. And for large commercial projects, if all they're doing is 5 kW residential systems, that's maybe not the strongest installer for your 500 kW project. So finding qualified installers, and we have some links in the toolkit to help you get the right groups. Okay, next. So once you have your RFP issued, you have proposals coming in, then it's a matter of scoring it. This is very subjective. How you and your school feel about risk, about a whole variety of issues. This is where you make those decisions in evaluating the RFPs and selecting your installer. We'll have a scoring rubric that we suggest in the RFP, but that's something that you can tweak to decide what's important to you. Once you select the installer, then it's a matter of negotiating a number of different agreements with them. They'll be different. The installers have their model agreements, and so we're not saying, okay, force them to use your agreement. But what the toolkit will do is to say, here are some of the key elements that you ought to include in your contract. Make sure it has these. For example, if you have a PPA, it's a very good idea to have some guarantee for your energy savings, some guarantee for what your output might be. Otherwise, you can find out that your PPA doesn't make some good sense. There are also things to watch out for. What happens, little outs and so on, other problems that may come and bite you later on. And so the toolkit will give you some warnings about all of that. They vary a little bit, whether it's direct ownership or a PPA or a lease, but we'll figure that out and have that in the toolkit. Next slide. Ron. Okay,
yeah. So is it now that you've selected the installer, whether it's a PPA or not, perhaps it's a facilities manager that really takes on a little bit more of this role, or a consultant, which is not a bad idea to have, because they're going to be the ones that can help support this project for the school. So there's a system design, and the installer will of course lay all that out in detail. In the equipment selection, there's the equipment it's more about equipment that is known from the different manufacturers that are out there. So that's going to be, I think, important to know, whether it's, there's going to be American-made stuff. There's not going to be much of it for a while, probably. So it's going to be coming from out of country in a lot of cases. But anyway, it's just really about the familiarity and popularity and the experience of the installer's selection of that equipment. Interconnection approval, there's two applications basically that have to go in place. There's the interconnection application to the electric utility, and then there's the permitting to the township. It's really important that the interconnection application goes in first, because that's going to take by far probably the longest time. There's been sometimes it could be several weeks to months before that can get clearance for you to move forward through the electric utility and their initial approval of the project. So that's an important step to definitely take on first. The permitting, of course, there for the township, there's going to be requirements there that you'll have to have on-site, site plans, electrical drawings, and stamped approvals, things like that going through, and that has to be signed off. Then after the utility signs off on giving you that first step to go forward, then the construction can happen. As it's being constructed, it's always good to have someone to make sure that what's being installed is in fact what was in the system design. After it's all been assembled, put together, there will be commissioning. Commissioning is really just making sure the system is working as expected. And commissioning really should be happening while the system is being installed as well. Like, okay, the plus and the minus are in the right places, things like that, simple things like that. But after it's all been put together, it's really testing the system. Is it in fact operating as expected? And after that point, then you have the electrical inspection that's done. The electrical inspection is done by, of course, either it could be the township having their own electrical inspector and building inspector, or it could be a third party that comes in. And this is a required part. This has to be approved, of course, that is passed on back to the utility for the utility to then go the next step for the final approval. But that electrical inspection, I should say, is really making sure that it's meeting National Electric Code 2017, and it's really on the point of safety. Passing an electrical inspection doesn't mean the system is going to necessarily be operating properly. That's why the commissioning is important. That kind of step is done independently. After everything is approved through the electrical inspection back to the utility, then eventually the utility gives the permission to operate, and you can turn the system on. Next slide, please. And this is finally the monitoring performance and maintenance kind of perspective. We talked about it's two examples of what monitoring look like. So down below is on the left side is the red is really the gross usage, regardless of whether that electricity comes from solar or the grid. It doesn't matter. It's really just showing the usage. The clear shape is the clear shape is basically the solar that's being generated. So you can see that during the time the solar is actually meeting almost all of the usage during those 2 days. These are 2 days of graphs here. But as I was talking about before, look at the spikes that are in both cases exceeding the height of what that solar is producing. Now, it is, of course, in the right graph, you see that very highest spike is synchronous to when the solar is occurring. So it will offset enormous amount of that demand charge. But on the left shape there, you can see that demand is really occurring outside of the window of when solar is occurring. So that's what's going to be your charge based on that high point, if that's in fact the highest for the month. On the right side is representing a very cloudy day. So you can see how much reduction that solar is providing in terms of reducing the peak. The upper is what we've seen before with a monitoring. You can see that it's just keeping track of the immediate generation in terms of power generation, as well as the cumulative energy that is being produced by the solar system. And this is, of course, good for for operating maintenance and for education. Back to you, Liz.
Thanks. We've got 2 more webinars coming up. We've got a webinar on June 8th. And this will give you a chance to talk with superintendents and principals and other folks who have already installed solar in Pennsylvania, and to share their lessons learned. One of the things that we're very excited about is that a number of schools who installed systems are already expanding those systems and going into phase 2, and some of them are planning phase 3. So there are, real success stories, and they are building on their success. So you'll get a chance to meet those folks and talk directly with them. And then webinar 3 is going to feature finance. We hope that by June 29th, we'll have all the final guidance from the IRS and Treasury and DOE, and we'll be able to give you definitive answers about exactly how all of the federal funding will work. It's possible that we will also know about other financing at the state level by the end of June, so that we will have hard financial information for you. We expect to publish the toolkit on June 30th. It'll be on the DOE website, it'll be on the PCA website, and it can reside, we can link to it from everywhere. So it'll be available to you at the end of June. Also wanted to let you know that the 3 of us, and particularly I'll say here, Roger and Bron, are available to provide technical assistance to your school now through the end of June. Our project with the DOE runs through the end of June. So we are available to you for technical assistance on your specific school. If you would like technical assistance, please contact me through email, and that'll be on the next slide. After June 30, on July 1, we're going to transfer the technical assistance to the Pennsylvania Solar Center. They have some funding from a private foundation to enable them to do technical assistance. on an ongoing basis statewide. So if you need technical assistance after July 1, we're going to just transfer that to the Pennsylvania Solar Center. It'll be a nice, smooth handoff. We work with them all the time, and they're really excellent. So just want to let you all know that this technical assistance is available now. I'm the gateway, so just send me an email, and I'll, depending upon what you need, I'll refer you to either Roger or Ron. And now we're going to take your questions. Any and all questions that I haven't already answered in the chat, please, I would say come off mute and just ask your question.
So I have a question. If we include solar into a GIZA project, does that still maintain the tax credits?
Roger?
It depends whether your GISA loan is tax exempt or not tax exempt. I believe GISA is tax exempt. The tax credits are preserved. It's just that portion of the project cost that is financed with tax exempt capital, rather than a 30% direct payment for that portion, it's only 6%. Now the adders also can be used, and so it increases those, but they're at a lower level as well. That'll all be explained in the toolkit. So it depends, is that tax exempt or not? And I think GISA is tax exempt.
Okay. House Bill 137 is in the works currently to push some funding towards valuation, whether it's a feasibility study and then possible implementation. Do you see that gaining traction in the House and being approved, or should we take the leap, or are there preemptive measures we should be taking prior to that bill being passed so that it makes us more feasible for that?
Representative Fiedler is leading the charge and is doing quite a full court press with press conferences around the state with different schools and so on. And so she's generating a lot of support for that. I know union interests are very excited about her bill as well. She's in before the governor now. The exact dollar amount that may be included in the governor's budget proposal has not yet been set. My sense is that some of this is likely to come through. How much, I'm not certain. So that's to be determined. What I would say is, if you look at our steps, though, there's a lot of work that can happen before you actually start nailing down the sources of the money that you're going to be using. So I would think that now's the time to begin the process. Keeping an eye out for what's available, and then you just have to make the decision before you pull the trigger. Should I wait a little bit longer to see if that EPA fund comes through, or the Green Bank money comes through, or PETA initiates some grant dollars, and then that's just a judgment call on your part.
Good. Thank you.
Hey, Roger, Mark Connolly here.
Yeah, Mark.
As you may know, RER Energy and other kind of missionary solar energy companies have tried to work in spaces like this with nonprofits to create a special purpose LLC.
Yep.
Many of the communities that we're in have very wealthy people who have tax liabilities. And as you know, the money that's being left on the table in everything we've discussed here is the depreciation of the project. And I just wanted to put out the table there and start a conversation, because I think that we could get something started that would have a lot of momentum, because I think there's a big pile of money out there somewhere in every community that wants to have a legacy, that wants to have a return on the money, that's the most cost-effective project with a reasonable return that can be negotiated. It's not a market return. And that really only has a 5-year horizon, because the depreciation typically is garnered in the first 5 years, and the project after that can actually be conveyed to the school district for full ownership.
Yep.
So I'm hoping this conversation can continue and maybe you can help. I know that the size of the project matters. It's a lot of paperwork. It's about 1 inch of paper for this LLC. But hey, you do it once and you get a template. It might, pass the lawyer's fee test of every project and actually create funding for these projects that is very tax efficient.
Mark, you're absolutely right. One of my favorite lines from the old comic strip Pogo is, "We are surrounded by insurmountable opportunities." And that's clearly the situation right now. There's a lot of capital coming in. People are figuring out how to deploy that. Your idea of the special purpose entities to capture that accelerated depreciation. Solar can be qualifies for the MACRS depreciation, so you can write off the cost in 1 year, in the first year. Other ideas that I've heard, the problem with the bond financing is it's effective if you have a bond need of 100, 200, whatever $1 million. It doesn't make a lot of sense to do a bond for just $1 million. But could Department of Education in the state or some other entity pool together different projects and aggregate them? So once the bucket gets filled and you have $100 million of solar, then do a bond issue for all of those projects together. And there's some examples in New York of multiple school districts co-financing, bonding their work. So there are lots of opportunities for creative people to figure out how we address this. I think the power purchase agreement is one example of that kind of creative thinking in the past. As you point out, the problem with ITC, if you're not paying federal taxes, it has no benefit. Same with the accelerated depreciation. So the power purchase agreement was the way to figure, how do we not leave all those dollars on the table? Let's find a for-profit entity that can be in the middle and claim the benefits and hopefully pass those on to the school. So lots of creative opportunities here. Liz.
Roger, there was one question about microgrids in the chat that I couldn't really answer. Can you and Ron take a crack at that? Would microgrids be a good application for schools?
Yeah, that's a growing field, of course. In fact, even last night I was with a little hub of folks on microgrid, coming out of New York. So yeah, microgrids is sort of, again, this up and coming thing. We think of a lot of these applications in a silo, I should say. You get solar, electric vehicles, storage. But actually, when you really combine all of that together, you're talking about a microgrid scenario. And that could involve the school, let's say, having solar and storage, but then also having expanding out to more of the community, so that, if there were an outage, for example, you could have several facilities all kind of working in a closed fashion off the grid on its own for resiliency. So that's developing. There's a lot of microgrid developers that are growing out in the field, and that is all I can say is that this is very fastly developing and coming down the pike really quick. It's a good application now.
Since I just asked a question real quick, also there's a lot of training in software and lots of jobs, because microgrids, those systems have to be operated through a lot of software and directing the energy in different directions. They're also good to install near firehouses too, especially, in cities or communities like that, so that they can all be operating like you just said.
Yep.
I just want to make the comment, thank you for the participants who are suggesting projects or documents or ideas in your chat here, because we'll take those, review them, and include them in the toolkit as we finalize it. If you have other questions, from your perspective, what are you worried about? What's your school district worried about? What has this treasurer told you about why he's not excited about solar? Well, any of that would be helpful to share with us as well, so we can address those concerns or those problems in the toolkit.
Can I just jump in one more time to put a plug in?
Yep, go ahead.
I just put in the chat a very hot topic in Phoenixville School District that we've been working for, and we finally have distilled our campaign into a very simple message. All electric plus solar equals 0 greenhouse gases. It's, you know, we're all working with regards to greenhouse gases and talking solar is really kind of code talk for greenhouse gas emission reduction. I think we need to bring this subject out, and I'd like to extend my help and a lot of messaging work that we've done to anybody that wants to get heat pumps into action and go straight to the greenhouse gas discussion.
Thank you. All right, so folks, with the time at 10:59, I am going to wrap things up. Thank you everyone for the great questions and discussion. I believe Liz did mention this. If you do have further questions and also for technical assistance inquiries, you can email her. I've posted her email in the chat. And I've also posted the registration links for our next upcoming webinars on June 8th, which is case studies of solar schools, and June 29th, paying for your school's project. Any last things you wanted to mention, Liz, Roger, or Ron, before we head out?
I just want to reiterate what Roger just said, which is really very important. We really want this toolkit to be responsive to your needs. So if you think of something else that is really burning for you as a school that you would like to see covered in the toolkit, please email that to me. Just let us know what you and also wanted to say that I'll go through all of the questions that we've received in the chat. If there are any that we have not answered, we will get back to you and answer those after the webinar. But I want to thank you so much for coming. This has been great. And I really want to thank Lane and Hillary for their amazing support and help. And frankly, it's just a whole statewide effort now to really help schools go solar. So it'll you'll be hearing a lot more from all of us.
Absolutely.
Yeah,
Thank you all so much. Have a great rest of your day.
Have a
Thank
sunny
you.
day.
Very good.
Exactly.
And may the 4th be with you.
Someone had to do it.
Yeah.
Oh, and I'm just seeing a request for the recording in the chat. Yes, the recording will be sent out next week. And the slides and any links that were shared from us will be sent over an email later this afternoon. So you can look out for both of those.
Great. Thanks
Thanks,
all.
everyone.
Thanks.
See you next time.
Bye-bye.